So this time last year, I was lucky enough to speak at the inaugural event that Emma organised. On that occasion, I worked for a company called Riskmetrics, and we were talking about how we were trying to do high-performance computing on public cloud infrastructures. In June last year, major change for us, we were bought out by MSCI Inc., and things have changed. So I just have to actually make a legal safe harbour statement that nothing I say tonight should be deemed as a forward-looking statement around MSCI and any of its business lines. A couple of other brief comments at the start as well, or one brief comment. And to be honest, a source of unbridled joy is that none of the presenters tonight have started their presentation with a slide that says, what is cloud computing? Right? And that's, for me, a significant, not a throwaway remark, a significant change on this time last year, when every presentation, every event started with what is cloud computing. It's become an accepted term and kind of part of the collective lexicon. And that's actually an important fundamental shift, I think, in terms of the way that the technology is viewed. So, with that in mind, look back at 2010, what were we doing and what were we about? Well, for us, 2010 was a year of business innovation on the cloud. Riskmetrics, now that business unit at MSCI, is all about high-performance computing and financial risk analytics, very large-scale computational problems. And as finance came out of the credit crunch and out of almost the end of the world, a return to quantitative finance means that in the long run, we're seeing a large demand and growth in complexity of financial models and therefore the compute requirements designed to drive them. And so what we did was we started looking at this particular area of using high-performance computing with cloud bursting to give us the ability to scale up and scale down our capacity based on our daily usage profiles. Because being a financial service provider, most of our clients found, we found most of the analytics for our clients needed to be run in the same time window, roughly 2 to 7 Eastern. And so we had a very, very high peak capacity, and then the rest of the day, very little. Classic, sort of predictable bursting pattern that suits a public cloud bursting model. So we engaged in that, and we did an awful lot of work. We built out broadly a hybrid architecture. So we do load generation on-premise, and then we burst out the pricing analytics from that load generation out to the public cloud, and reached the point now where we can essentially treble the number of compute instances in our production infrastructure in 32.5 minutes, all based on the Azure cloud. So just ahead of our runtime when we want to do things, we just spin up, say, 4,000 or 5,000 instances on the Azure cloud, and we can link that into our on-premise load generation and rip through the stuff, letting the capacity go at the end. And it works. We can achieve 95 to 96% utilization of CPUs across the cloud infrastructure. So, a successful hybrid architecture. However, it comes at a cost. We implemented over 50 separate REST APIs to the cloud to do the command, control, configuration, communication, log integration, situational awareness, and all the other stuff you need to do in a hybrid architecture to actually make it work as an actual implementable solution. And that's a significant amount of complexity, given the fact the actual analytics flow was just one of those APIs. So significant body of work in testing in all the non-functional stuff around the hybrid architecture to make it work as a solution. But a couple of key takeaways we took from all that work. One was that architecture matters. The architectural principles and patterns you use when building a cloud solution are critical to their success, their operability, and their general robustness and scalability. So architecture matters. And the second one was that we learned from our approach to with hybrid architectures, it's best to centralize the configuration and control in the cloud. All the on-premise load generation components we do pick up their configuration and startup information from cloud-based APIs, because it's the far best architectural pattern to make that particular hybrid bursting work. So lots of technical learnings from last year, but fundamentally, we enabled ourselves to, on demand, increase the throughput of very complex asset processing by a factor of 10 just by using this particular kind of technology. So, successful from our point of view. So now looking ahead in terms of general statements about direction, nothing specific about where we particularly may be innovating. For me, 2011 is going to be a year when we see particular innovation around the issue of platform as a service. Andrew talked eloquently about the extremes of investment and the fact that platform as a service hadn't really taken off, at least in the same level of investment. I think there's going to be some very interesting innovations in this area through the course of the year. The acquisition of Heroku by Salesforce, Elastic Beanstalk from Amazon, the rise of Java and PHP as first-class citizens on Azure, all of this points in the same kind of direction, which is at the moment it's a race for developers, right? That's what the game's all about on platforms as a service. I think in terms of innovations, there's going to be 3 principal motivations around the kind of innovation we'll see. And the first one is simplicity. I've just said that our implementation of our solution was highly complex in terms of the kind of integration work we had to do. In terms of this year, we intend to simplify it greatly. Okay? So all the custom code we built for log integration will hopefully shift off to a third-party provider of logging services who will do all that integration for us. We'll just log to their APIs in the cloud, and we'll pick up the logs on-premise, and we don't care about the plumbing in between. We'll move to using System Center to do the spin-up and situational awareness of stuff on the cloud and get out of all that homespun stuff that we've done. We'll move to using the HPC operating system we have on-premise and its elastic stretch out to the cloud that Microsoft's engineering with its HPC linked to the Azure platform. Fundamentally, we'll simplify our job. Most of those APIs will go away. We'll take commoditized solutions to do most of the hard work, and what we'll focus on will be the actual analytics that we're distributing and the data and the design and the load balancing. So a lot of that stuff is about simplification of the job, in our case, around hybrid architectures and HPC. But it's interesting that this kind of points to two key fundamental drivers of cloud in general, which I think it's important to bring out at this stage. The first one was this idea of commoditization, right? Essentially, what we want to do is we don't believe in the future that in HPC, high-performance compute problems, there is much competitive advantage in the underlying distribution mechanisms. That's going to be a commoditized service from any number of providers, principally in our case from Microsoft. So there's no point us investing R&D dollars in reinventing that particular wheel when very shortly it's just going to become something you can buy as a service, potentially as a tick box. Right? What this focuses on is differentiation. I think platform as a service is going to focus a lot of minds and a lot of investment decisions around the appropriate level of abstraction at which you work. And the mantra we have is this one: commoditization at the point of abstraction. So essentially, if you can abstract away as much of the complexity of being on a cloud platform as you can behind some level of API or some development fabric, then you're going to get the maximum bang for your buck out of your actual research dollars. So, for example, I think with the Google hint about App Engine for Business, you could imagine there how Google could potentially abstract away an awful lot of the complexity of doing some very high-scale search and other compute-related topics, wrap it up nicely in Development SDK, which you can then leverage quickly to do some very interesting problems. And I'm not looking for a nod or anything, but I'm assuming there's something in that direction. Likewise, Microsoft's got a technical computing initiative, which again is designed to put big data problems on a very accessible productive scale, such as functional programming languages over the top of distributed file systems and MapReduce and so on. So there's a lot of innovation going to come out of these particular development of fabrics and abstractions. And I think that'll be a key thing, whether it's open source, whether it's commercial fabrics, we'll start seeing specialist development environments and capabilities, maybe for particular kinds of problems like high-performance compute, maybe within specific industry verticals around biopharmaceuticals, computational biology, finance, whatever it is. So that specialization and that focus on abstraction in platform as a service, I think, is going to be a key trend through the year. So based on our experience then of essentially doing high-performance computing on hybrid architectures and this sort of view we have around the direction of platforms as a service, I'll pick out a couple of trends for the year, and which will hopefully lead nicely into a panel discussion about what these trends really will be. So the first one, I think, is ISVs are going to move to the cloud. We haven't really, in these events, talked much or heard much about ISVs. Much of the debate around cloud tends to focus on the enterprise cloud and enterprise IT and infrastructure as a service and and software as a service moving as business users. There's a whole raft of innovation out there in the software vendor community who are starting to get their heads around software as a service as an offering and what cloud computing means. And Larry Augustin, who's one of the founders of Sugar CRM, he has an expression for this. He calls it SaaS 2.0, a little bit tongue-in-cheek. But again, coming back to one of the comments Andrew made, there is no point if you're an ISV thinking that the route forward to software as a service is getting your data center, building your infrastructure, building right? Complete waste of money. No differentiation in those parts of the services whatsoever. You should be programming at the maximum point of commoditization you can achieve, focus on your business problem, and get your software out as software as a service. And I think that's a trend we'll see strongly from the ISV community. I think also the ISVs this year will realize that moving to software as a service and aggregating the data they get from clients adds huge business value. There's a great expression now, which is that, I've got to get this expression right, which is that statistical significance is the new economy of scale. In other words, if you're a provider of services and you have a statistically significant sample of data from your client base, you gain insight, right? There's a Microsoft Azure customer called Margin Pro in the States, does bank lending software. In the first 8 months, I think they established about 700 middle-tier banks in their margin lending business, software as a service. The point being, at that point, they knew more than anybody else in the US financial markets about loan pricing in the US. Little software company, software as a service, had complete statistical insight, significant insight into the loan pricing market, and therefore trends, real interest rates that are being observed in the real economy in the United States. A phenomenally powerful position to be in as a little ISV. And you can see this in particular ISVs. They've got to grasp this idea that there's huge inherent value with having client data aggregated in the same place on the cloud. So ISVs, big area of innovation for this year. I think the other one, coming back to a hybrid architecture, is this one. Local infrastructure as a connected device. The expression connected device comes from Ray Oz's exit memo from Microsoft, where he talked about the world being part of connected devices and continuous services. I think most people potentially misinterpreted what he meant by connected device. I think he sort of meant it was a play at these things and about the strategy around mobile. But essentially, there's all kind of innovation we're already seeing around the idea of locally placed infrastructural devices, particularly storage devices. We have on-premise storage linked to backup storage capacity in the cloud. And so I think that one area of innovation we'll see through the rest of this year is this idea of significant parts of local infrastructure start being cloud-managed local footprint. And the ultimate endpoint of that, of course, is the Microsoft Azure appliance, where you can literally effectively take a container load of Azure and dump it in your own data center, but it's connected to and managed from the Azure cloud itself. We can see potentially the opportunity to do local appliances, which are just basically very fast reaggregation boxes of data, but where all the heavy lifting in terms of pricing, for example, financial instruments, is done off in the cloud. So again, I think an interesting theme in terms of connected devices for the year. So I'll leave it there. I've been rattling through, but I'll leave you those two thoughts about the year, and then we'll see what the panel has to add. So thank you.